Hey, Bio 1 students, for Shiance again. We're going to start with 2.4 notes. We finished 2.3 last week. We got just about 3 days of 2.4 notes, and then we should be good. So we're still in chemistry. We're done with the macromolecules, so please get that macromolecule foldable done for me. You're going to use it on your test next week. So our test will be a week from tomorrow. So Tuesday, a week from tomorrow. Okay. So let's look at chemical reactions and enzymes. The big thing is, how do chemical reactions work in the body, and how do enzymes work in the body? So let's start with chemical reactions. If you have a highlighter, highlight what's in red. You don't have to put anything in a foldable this time, but good test questions. Living things are made up of chemical compounds. We talked about that earlier in notes. Um, we are just loaded with H2O, CO2, CH3, whatever, ATP, DNA. It just goes on and on and on. Carbohydrates, lipids, all those macromolecules we went through. So chemistry is basically what life does. Okay, so that's the function of living things is chemical reactions. Nothing occurs in an organism that's not a chemical reaction. So all of our life processes, all those characteristics of life, growth, interactions, reproduction, movement, all those things we talked about is based on chemical reactions. So let's kind of break that down and talk a little bit about what are chemical reactions, what are they exactly, some terminology, and how do they impact our body on a daily basis. So a chemical reaction is a change or changes or transforms one set of chemicals into another set of chemicals. And we do that by joining them with chemical bonds, and we join atoms together in compounds. We talked about that earlier in notes, okay? Now, a little basic review. I know you've been taught this, but just so you know, and I got a funny little video here. I watch slow-mo guys in my class a lot, so I'm going to play this video in just a second. But mass and energy are conserved. Okay, so during a chemical transformation, energy is never created nor is it destroyed. It just moves from one form into another. And you're going to see this. This is a slow-mo video where the volleyball is going to have momentum and energy. It's going to hit Dan in the face here, and you'll actually see the energy transfer over to his face, and the ball literally will stop. So let's watch this video real quick, and then we'll sum it up, and we'll talk about it. All right, so here we go. If I can make it play here. Maybe. Maybe we can, maybe we can't. Let's try this. Changing gears a little bit here. Here we go. Let's see if it'll work now. If not, here we go. We got it. So here's the slow-mo guys. Watch what happens to the ball.
All right, well, this is my favourite part of the challenge. I don't know about yours. This is a football or soccer ball, depending on where you're watching this, filled kind of all the way up with water, so it's got a bit more weight to it. And I'm going to throw it really hard at the side of your head.
Thanks. Brilliant.
I reckon expose the teeth, and I want to see eyes wide open, just so you get the full extent of stop movement. Ready?
Now you can watch here. Watch what happens to the ball. The ball literally will stop, but watch where the energy goes first. That is a conservation of energy right there.
It's like one of those Newton's cradle things. The ball just stops dead and then your head carries on at the same speed.
That's ridiculous.
Look at this. I reckon this should be your Facebook profile.
Okay, I think you get the idea there. All right, so that's basically, as you can see, energy just gets transferred from one form to another. Okay, now here's the last couple things I want to go over today, and I'm not going to go through the videos with these. You can kind of look at them some other time. I will post them eventually. If you want to look at them, you can, or look them up on YouTube. They're pretty funny to watch. But the elements or compounds that enter a chemical reaction are known as reactants. So when you see a chemical formula, you have a set of elements or compounds on the left side of the equation, and you got an arrow, and then you have the right side of the equation. That is basically reactants on the left side, products on the right side. It's very similar to 2 times 2 equals 4. 4 is the product, right? So the elements or compounds produced are called products. So this is just a little introduction to those two concepts. Pretty simple notes today, but I just kind of want to get this started. I got short periods today. We have a fog delay here at school today, so I'm only going to have 30 minutes to go through notes. So I'm going to keep them short today. You guys are actually right on target here. The notes you're seeing right here are the same ones I'm giving in class today, so we're caught up. All right. So hey, have a good day. We'll talk to you later down the road. See ya. Bye.